All right, in 5.5, some more examples of negative exponents. All right, so we have this guy here who has, we always have to follow order of operations. So the first thing we're going to have to do is, inside of this parentheses, there's two bases. There's an X and there's a Y. Those two bases are touching the floor, basically. So both of those are going to receive this negative X that's on the outside. We're going to have to distribute him inside. However, they both already have an exponent. So this one was y to the negative third, but now he's getting a negative 6 also. And the rule says if you already have an exponent with your base, then you take the two exponents and you multiply them. So that'd be y negative third times the negative 6, and negative times negative makes it to be a positive, and 6 times 3 is 18. So that becomes y to the 18th. Well, this is x to the 6th. So we bring this x to the 6th over, but then we have to distribute this negative exponent to him, and he gets a negative 6 as well. And so we have x to the 6 times negative 6, which is a negative 36. So we have negative 36. So what we now have is y to the 18, let's write this right here, y to the 18 over, or well, at the same place, we have negative 36. Well, we're not finished yet because we went ahead and distributed this, but when we distributed it, one of our bases ended up with a negative exponent. Well, the only one that has the negative exponent is the x. The y's exponent is fine, so we're going to leave the y and his exponent because they don't have a negative exponent. We're just going to move the one that has the negative exponent, which is the x. So the y to the 18th is going to stay on top, and then the x is going to go to the bottom, and when we move the x to the bottom, it then becomes x to the 36th. They don't have anything in common. One's y, one's x's, so that's our final answer. All right, so the next problem we see, it has a negative exponent on the outside as well, so we have to distribute it. This time it has a 3 base, an x base, and a y base. So we have to distribute this negative 3 to all those bases, to the x, to the 3, and also to the y. All right, so we distribute it to the 3, it becomes 3 to the negative third. Distribute it to the x, it becomes x to the negative third. And then we distribute it to the y, and he has a negative third as well. Well, they all have negative exponents. So all of them are going to have to move position. Every one of them is going to have to move position. These both have negative exponents. So this time we're going to move both of them down here. And that guy also has a negative exponent down here, so we're going to have to move him to the top. So what was on the bottom is now on top, and what was on bottom is now on top, or vice versa. So y to the negative third becomes y to the third when I move it. And then 3 to the negative third becomes 3 to the positive third. And then x to the negative third becomes positive x to the positive third. If they're y's and x's, they don't have anything in common, so I can't reduce those. However, this 3, I can do that math. What's 3 times 3 times 3? 3 times 3 is 9. 9 times 3 is 27, so this becomes y to the third over 27 x to the third. All right, and then the final one is a little bit bigger, but again, we're still having to distribute that exponent into all the bases. So the y's, the x, the negative 2, this y, and this x. So he's going to go to a lot of them. So I'm going to do every baby step. So the negative 2 is going to get a third exponent. Oh, I'm about to lose you. Sorry. Then the x already has an exponent, but he's going to get another one. So he already had a third with him. So now we're going to bring a negative third with him. Or no, I'm sorry, a positive third too. Bring that 3 over. Then we have a y. He doesn't have an exponent to begin with, but he's now got a 3 over x. He didn't have any exponents, but now he does. He has a third. And then y to the negative 1. He already had an exponent, but now he's got another one, which means we're going to multiply them. All right, so negative 2 to the third. So we're actually only cubing the 2 because it's only up against the 2. So the negative is just going to get brought back. It's 2 times 2 times 2 is 8. And then x to the third times 3. Well, 3 times 3 is 9, so that's going to become x to the 9th. Y to the third over x to the third. And then y, -1 times +3 is -3. All right, so at this point, we need to get rid of that negative exponent, right? So we gotta get rid of this negative exponent. He's the only one that has a negative exponent. So he's gonna have to move positions. He's gonna have to move up there. So they're still gonna have a -8, x to the 9th, x to the 9th, y to the 3rd, but I'm also bringing this guy up, so there's another y to the 3rd over x to the 3rd. All right, so now it's just like combined like terms. Do you have anything that are the same? Well, I have some x's on top and x's on bottom. Well, the rule says that if they have the same bases, then you take their base and you take the first exponent and subtract it from the bottom. So if I drew out 9 x's and 3 x's down here, how many would cancel out? They both have 3 in them. So 9 minus 3 is 6. So we're going to have -8 still. Now the x's becomes x to the 6th. Now what about these y's? The y's, they have like bases too, but what are these bases doing to each other? They are multiplying, and the exponent rule says if they have the same bases and they're being multiplied, then you take their exponents and you add them. So it's 3 plus 3, which gives me y to the 6th. And we no longer have anything in the denominator. Our answer is just -8 to the 6th, y to the 6th.